And welcome to Chapter 2, Section 3. We are now talking about solving multi-step equations. So we've already worked on solving single step. Now we'll be able to solve a little bit more complicated problems. So now we'll see more than one operation in the same problem, and we'll be able to solve those with a few steps. We'll see consecutive integers, and we'll talk about those as a rule that we need for this section. So we know we'll see some multi-step equations. There will be consecutive integers, and we'll talk about some numbers that we're going to see. So our first example, we're asked to solve this expression. We know it's going to be more than one step, and we need to check our solution. So the first thing we need to do is just have our original equation. After we have that, we know our variable here is q. And in order to solve for q, we need to get it by itself. So the first thing we can do is get rid of this plus 11. And to get rid of addition, we have to do the opposite, which is subtraction. So we'll subtract 11 from both sides. Again, whatever we do to one, we have to do to the other side of our equation. So on the left side, the 11s will cancel out. On the right side, we will get a negative 8. So that's one step down. And we need one more step to solve this. So 2 times some number q will give us a negative 8. What is that some number? And if you can't tell, you can get q alone by dividing away this 2. This 2 and the q are tied by multiplication. So to get rid of the 2, we have to divide by 2 on both sides. So on the left, the 2's cancel out, we get just q. On the right, we get a negative 4. So q is negative 4. That's a solution that we think is correct. And now we should go back and check that solution. So if we plug in a negative 4 into this equation, would it check out? Well, 2 times negative 4 is a negative 8. Negative 8 plus 11 is a positive 3. That is a true statement. So this is our correct answer for 1A. 1B, we have to solve for this whole thing, and we want to check our solution. So our variable this time is k, and we know we want to get k by itself. So our variable here is k. We need to isolate that and get it by itself. So we see it's being divided by 12, this whole left side. So if we multiply both sides by 12, that will get rid of this denominator and we won't have a fraction. That's always something that you're going to want to do. So first thing we do is multiply both sides by 12. The 12 here and here will cancel out. So we'll get just k plus 9. On the right side, we get 12 times a negative 2, which is a negative 24. So one step down, we need one more step to solve for our variable. So we have k plus 9. Some number plus 9 will equal negative 24. What's that some number? Well, if you can't tell, we need to do the opposite of addition to get rid of this 9. So we'll subtract 9 from both sides. And on the left, the 9's cancel out. We get just k. On the right side, we get negative 24. Take away 9 more, a negative 33. And of course, we could go back and check to see if a negative 33 works for our problem. So negative 33 plus 9 divided by 12, does that give me a negative 2? And you could go back and check and see that yes, that does in fact work. Negative 33 plus 9 would be a negative 24 on top. Divided by 12 would be a negative 2. It checks out. We know we're doing the right thing for that problem. 1C. So we have 4 potential answers here. Our variable this time is v. We need to isolate that variable. So if we circle our variable here, we know that v is what we need to get alone. So v is tied by multiplication to the 6, and we're also adding 7. So the first thing we have to undo is the addition here. Addition is just hanging there. We can easily subtract that away. So if we subtract 7 from both sides, on the left, this will cancel out, so we get just 6v. On the right, we get negative 5 minus 7. That's a negative 12. So 6 times some number will give us a negative 12. If you're not sure what that some number v would be, We need to get rid of this 6. They're tied by multiplication. So we need to divide that 6 away. And we'll do that to both sides. So on the left, the 6's cancel out. We get just v equals. On the right, we get negative 12 divided by 6. 12 divided by 6 is 2, and we'll keep the negative sign. So v must equal a negative 2. Now, if we want to go back and double check, does this solution work when we check it? So 6v plus 7 equals a negative 5. So when we substitute in a negative 2 for v, is this a true statement? So let's do that. 6 times a negative 2 plus 7, does that equal our negative 5? Well, 6 times 2 is a negative 12, and we'll add 7. Negative 12 plus 7 is a negative 5. And on the right, we already had that negative 5 value. So is this a true statement? Absolutely, it checks out. We know our answer should be A for 1C. V must equal a negative 2. 1D asks us to solve for the variable j. So we have a couple things here. We need to isolate our variable j. So the first thing I want to do is get rid of this denominator. It's dividing everything on the left, so we can easily multiply both sides by a negative 6. So if I multiply a negative 6 here and a negative 6 here, on the left side, this will cancel out. So now I got rid of my denominator. That makes it much easier. On the right, we'll get a negative 72. You can check that in a calculator if you'd like. So over here, we just have our numerator, negative 4j. And I know minus a negative 4 is the same thing as plus 4, so I'll just write plus 4. So negative 4j plus 4 equals negative 72. So one step's down. We need 2 more steps to solve this. So this plus 4 is just hanging here. We can easily subtract that away. So I will subtract 4 from both sides. If we subtract a 4 from both sides, we did to do the same thing to both sides always. So this will cancel out. We'll get negative 4j. On the right, if you have negative 72, you take away 4 more, you get a negative 76. Good, so we're making good progress. Now we need to divide away this negative 4. Since this is tied by multiplication, we have to do the opposite, which is dividing. So divide away the negative 4. We have to do the same thing to both sides. So this will cancel out. We'll get just j on the left. On the right, we get a positive 19. Notice negative divided by negative gives me a positive 19. This will trip people up. Negative over negative, always positive. So j must equal 19. If I look at my available choices, it must be C. And we could go back and check to see, is that in fact true? So negative 4 times 19 plus 4 divided by negative 6 would in fact equal 12. So that would be a check for our problem for 1D. So example 2, first one is about shopping. We see Susan has a $10 coupon for the purchase of any item. She bought a coat that was half of its original price. So let's circle what's important. Half of its original price. After using the coupon, she paid $125 for the coat before taxes. We want to know what was the original price of the coat. So we can write an equation and solve it. So she bought a coat that was half of its original price, and she paid $125 for the coat. So what was the original price if half of it was 125? And she had a $10 coupon. So let's think about that. So 1/2 of the price minus $10 is what she paid, 125. In other words, 1/2 times some price P minus 10 would equal 125. So that's an equation. This is going to be our equation that we use to now solve our problem. So it's easy if you take it step by step. You circle the numbers that are important and then think about how they're used. So we know she paid half of the original price, and we know the number she paid was 125. That's what it equals. She also had $10 off, so let's just subtract 10. So that's where all this in our equation came from. So there's our original equation. Now to solve this, we just have a couple steps. We want to add 10 to both sides to get rid of this. So that will cancel out. On the right, we'll get 135. Half of the price is 135. What must the price be? If you're not sure, we can get rid of this 1/2 by multiplying by the reciprocal, which is 2. So multiply by 2, that cancels out the half. On the left, we'll get just P. On the right, we get 270. So what was the original price of the jacket? It had to be $270. That is our solution for this real-world example. So 2b, we have 3/4 of the difference of a number, and 7 is -15. We want to know what is the number. In other words, we need to use the skills that we've honed with taking a sentence and making it into an equation in order to answer this problem. So 3/4 is just a number. So when I see 3/4, I will write that fraction. 3/4 of means multiply, so I'll just put a parenthesis. 3/4 of the difference of a number and 7. So this whole phrase, the difference of a number and 7, is subtracting between a variable, we can call that x, that's our a number, and 7. So in here we need to have the difference of some variable x and 7 is means equals, and -15 is just a number. So given all this, we want to know what is the value of x. So we now need to multiply by the reciprocal of 3/4 to get rid of this fraction so our problem is easier to solve. So let me switch my pen color so we know what we're working with. So now we need to do the same thing to both sides, which would be to multiply by 4/3. Why do we choose 4/3? Because I know that multiplying by this reciprocal of this fraction will cancel all of these things out. And then we'll have just 1 over here, and we're closer to isolating our x. So 4/3 there, and 4/3 here. On the left, we'll now have, if I switch colors again, on the left, we'll have just x minus 7. On the right, we see 3 goes into 3 once, 3 goes into -15 5 times. Don't forget the negative. So we have now -5 times 4, which is a -20. So some number minus 7 equals a -20. If we add 7 to both sides, x will equal, what is -20 plus 7? If I write in my step here, plus 7, this will go away, plus 7 here. -20 plus 7 is not -27, but a -13. So there we have it. That's our final answer for 2b. So we've also got some consecutive integers to talk about. So we know that consecutive integers are just one number, the next number, the next number. So the symbols we use for that are n plus 1, and n plus 2. For consecutive even integers, we're going to skip a number. So it's our first number, then we skip one, then we go to the next number, and two more, and two more. So when we write the symbol for that, it's some number, then that number plus 2, then that number plus 4. If you think about it, 0 is a number, then we add 2, that gives us 2. Then we add 2 more, that gives us 4. So those are our consecutive even integers. It's the same symbol for odd integers, just knowing that we have to start with an odd number, not an even number. So the same symbol works for that. Of course, consecutive integers are just 0, 1, 2, 3. These are the symbols for that. Some number, then the next one is just plus 1, then plus 2, and so on. So we can use that to solve a couple problems. So in this example, we're asked to write an equation for the problem below, then solve the equation and answer the problem. So we need to find 3 consecutive odd integers whose sum is 57. So if we let n be the lowest odd integer, n plus 2 would be the next one, and n plus 4 would be the greatest of these, because we have to skip a digit each time, right? If we start with 1, the next one can't be 2. 2 is even, so it has to be 3, which is 2 more digits. So n plus 2, n plus 4 are 3 consecutive odd integers. We have to add them together because their sum is equal to 57. So the sum of these integers, which is n, the first one, plus the second one, n plus 2, plus the third one, n plus 4, equals 57. That's our equation. And now we can apply that equation to solve the problem. So now we can combine like terms on the left. We have 3 n's. This is all addition, so we can move it around however we want. So we have 3 n's, and 2 plus 4 is 6. If we subtract 6 from both sides, 3n equals 51. And if we divide both sides by 3, in one final step we can solve for that variable. N has to be 17. So if the first odd number is 17, that means the second odd number must be, the next one is 19, and the third one is 21. So the 3 consecutive odd integers must be 17, 19, 21. If you're confused about the vocabulary, consecutive just means they have to come one after the other, right, in order. So there's our solution. The consecutive odd integers are 17, 19, and 21. So we will see a few problems like this in this section. So here's another example. If we're asked to find 3 consecutive even integers who add to 84, we could do that. And we know that it would have to be n plus, the second number is n plus 2, plus the third number is n plus 4, and they will sum to 84. So if we combine like terms just like last time, we have 3 n's here. There's an n there, an n there, and an n there. So 3n plus, 2 plus 4 is 6. So 3n plus 6 will equal 84. If we finish out that step, 3n, if we subtracted 6 from both sides, 3n would equal 78. And if you divide both sides by 3 in one final step, n would equal 26. Now you have to remember what this means. This means that the first number is 26. So if the first number is 26, then we know the next number, we're talking about consecutive evens, the next one would have to be 28. And the next one after 28 is 30. So that's how we generate this solution, B, for this example. So hopefully you're feeling confident about this section as we head forward and start our assignments for today.